You gotta have. Or
Exactly.
should be in zip folder.
Whoever's off and down when it's in seven.
Okay.
Just because I know how it works as a zip, you mind if I download it as a zip?
Sure.
Okay.
Okay. So let's start our database. For this lecture, like even on Monday, on Tuesday, it kind of overlap with the database. So we're talking about how to design. Okay, so because it's really important, is like part of your system. So UI, the server, and then some function, and then finally, how can we store your data? So we have two types of database, relational, and also we have the NoSQL. And when we need to design your database, and when we talk about the primary key, so what are the attributes, and then how to design a candidate keys and primary key. So I kind of assuming like some of you took the database course before, so I assume you should have some understanding. And then last time we did the exercise, so I'm asking how can we transforming from ER diagram. So if we have a many-to-many relationship, how can you draw class diagram, like changing it? So I think I did create the exercise, and let, I think it's in class exercise, right? Okay, I saw some of them you already uploaded. So you need to draw a class diagram. So like from 2 tables to 3 tables with the intermediate. Yeah. So if you able, also the relationship. So I'm asking where is the relationship? So if we are changing one many to many, so suppose when we draw the table, it should be 1 to many and many to 1, or 1 to many, like this. Okay. And we have the primary key, so training for designing like to be like unique and identical. And then we have a foreign key, so it's like from other table. And when we design, and sometimes when we learning in when you actually here's a slightly difference when you learning, maybe in the class we learning that what's the candidate key, or like or we have like different combining several attributes together be a primary key. But in actual practice, we always create one called the using the table name and then with the ID. Okay, so it would be faster and then easier for us to retrieve it instead of the like combining 2 different key attributes together to form the primary key. So it's an association between the 2 classes. But for our system design, so I'm not sure, not only the relationship like is 1 to 1, 1 to many, many to many, but also I'm asking the cardinality. So that means like I need to see you are telling the range, minimum and maximum. Okay. So right here, in here will be the association example between the rows in 2 tables, the key and then the attributes. So this one will show I have 1 unique primary key. So 1, but I will show up right here. So it will be 1 to many relationship. And then I'm asking if for cardinality right here, maybe what's the minimum? Maybe we never have a products like showing right here inventory, or yes, then will be 1. The minimum, or if isn't, it may not show up right here in this table, that means it could be 0. Okay, minimum and maximum. And then we have certain steps like create the tables, choose the primary key, add the foreign key, and then if we need to represent the many to many association, then we need to create new table. And then we need to represent the classification of hierarchy, and then define the referential integrity constraint, and then evaluate the schema quality and make the necessary improvement. Okay, and then choose the appropriate data type. So all the data type we talk about metadata. So they will describe your tables. and then incorporate the integrity of second control. And finally, you should able to see the diagram. Okay. Because maybe for your project design, and you may not really implement everything like actual create table and then select it. So most of the time you will represent your tables like showing in this like diagram, and then you will create a if you running on the MySQL, then you will have a .SQL file. And those SQL file will including like create the table and then insert those data if you need to update or like you need to change certain attributes to a primary key indexing or like, setting the auto increments. So do you know this kind of thing like using the .SQL file and add those? Anybody knowing how to do that? .SQL file. Well, I know somewhere when you learn database, you using the MySQL, what's the name? Workbench. Okay, so you just like execute the SQL statement, the query, right? But do you know when you can export it, save the file, .SQL file? Do you know how to do that? And or how can I create a file and then I can just like when I execute this .SQL file, then I will automatically like create the folder the tables and then insert all the data.
Would you just have the executor run the creation like text or code to start up to open up create everything as once it executes?
Yeah, just like input a file. So okay, so if no, so maybe for the system design, you need to prepare the file. So like I'm not able to like able to check your computer, right? Then how can you like tell me, okay, how your database design, how it looks like? Then you need to give me the SQL file, okay? So for the initialization example right here, the table, so you will show table names, what are the attributes. Actually, when you have all the class diagram, then it means the same things. So I able to know. So here's my example. And then we're showing the different relationship, one to many, many to many, and then we need to add a class. Okay, more. So finally the tables looks like this. Okay. So when we designing the relational database, so we say, how can we know the relation? So we need to make sure that referential integrity. So they must be like consistent. And then the constraint is they store in the schema. So they will use it to automatically enforce the referential with integrity. Especially you use the foreign key, and then in other like the primary key used in other tables as a referral key. So sometimes when we check, if you need to delete your table or drop your table, then they will validate. Okay, so if you have some if you are using those primary key in other table as a foreign key, they will pop a message you're using it, you're not allowed to delete. So we do have some schema. The RDMS is going to like validate all these things. And next we have a normalization. We have normalization, like first normal form, second normal form, and third normal form. Okay, so when you learn the database, what is the first, second, and third normal form? So what they're doing? Anybody still remember? The kind of like definition, but not really. No,
Like we went over it some, but it wasn't like a
big focus.
what tables you have, right?
Not really. Not the table. Yeah.
Everything is stored in one table.
Mm-hmm.
Like the third, everything was its own table. And I think he indicated that if you ever went beyond fourth, it was very strange. It wasn't very normal for that to happen. That sound familiar?
Normalization or like any idea? Actually, when you submit, actually for the question, we barely really asking like what's the first step, but you need to know what we are doing. So, for the first normal form, it's just to make sure all the field only have one value. Okay. So one specific, just imagine it for the Excel. Okay. Sometimes would you put everything in one single cell, or but for database, we need to make sure one cell is only for one type of one piece of data. Okay. So right here, let's say I have so many my SSN name, department. So if I before that maybe I using one row and then insert all of them together, or I combine everything together. So it doesn't meet the first normal form. So we need to like break down to like one row have one record. If let's say I have a multiple items, then I need to maybe most common is about maybe the orders. Okay, so the let me use the word show. File. Okay, maybe I forgot the user. Okay, John. Okay, maybe I have a other items, right? Okay, so right here I have Apple, and then maybe I have a pen. I don't know. Okay, or something. I have a box. If we are doing this way, it doesn't meet the first normal form. Then we need to change it. How can we let it match the first normal form? So if we're doing this way, so yes, we need to create one more row like this, like this. Okay. So it will be look like this. So it's the first normal form. Okay. So suppose like if you are saving certain data, then we need to break down. Then you say, oh, it looks so stupid, but then we have some called the duplicates, like redundancy, because the username repeats so many times. Okay. So here's a reason why we sometimes try to create maybe one more things about the user account and then using an ID. So we'll compare if I using the index, the primary key, using a number. Even without the knowledge, if I using called the user ID, if they say user name one. Okay. Let's say if I'm doing this way, which way do you prefer? A1, A2. Okay. So why now if we fix the problem? Okay, so after the first normal form, we put all those like row only save one single item. Okay, in one single cell. This one is a enhanced question. Am I just putting a name, or will I put the user ID? Putting a number, or what's the reason? Actually, it's giving the same result, no matter the username or the ID. But which way do we prefer? Which you prefer? Why?
Every time you roll the things.
If I assume all the name is unique, both of them are unique. Okay, this keyword is shorter. Okay, why is it important? It's shorter. Second question, why?
Small.
Okay, smaller, less time.
Reduces the data your database takes up.
Okay, save it. Okay, because like, here's like a question: when you design the system, you need to ask like why you're designing in this way, or like why we make it this way. Say smaller. Okay, why not? It only have three rows. Yeah,
Integers are much easier to work with than strings.
integer also. Okay, if we know the bit like for integer, maybe we are using 1 bit to save it, or 1 byte. Okay, but how about a string? Or sometimes we will declare, if you know the metadata for string, we're using the varchar, varchar. Like sometimes we declare like maybe 12, 15, or like maybe 255, the maximum 255, the size. Oh, okay. So right here, if I take like 255 bytes to save it, or I use 1 byte to save the integer, which one is better? Of course, like if I have 1 million, 1 billion record. So when you decide, of course, I want to save my storage space and also for faster. So for integer, like we talk about, here's the reason, like faster to access, maybe we create the index. Of course, like you say, I can compare the string. Of course, it is okay using indexing, we can access faster. But for integer, we know it's even faster, okay? And we can save the space, giving the same result, okay? So for the efficiency, so far that's why in the habit, maybe in the school, like some when they teach you, yeah, we have like candidate key, like combine two different fields to form the like primary key, or when we have many tables, and we will create a new table, right? And you will put in, maybe you say, okay, let me use 2 tables primary key to form the like together as the primary key. That's like this. But in practical, we always create a new primary key and then save them because it will be faster. If you are not so sure, I'm talking about, let's say, the example what we using, we are using. Do you remember on Tuesday, what's the example I'm giving to join? Once the order and then product, right? Okay. So if I have 2 tables like order and product, and then both of them, we do have the primary key. Let's say I have right here, right here. Maybe here I will call the order ID, and then I have a product ID. Okay. Because this one will be a many-to-many relationship. Okay, so the associate, then we will create one more of a new table and then save it, and then maybe I say sometimes we purchase transaction, wherever any name. Maybe this time I call it like transaction table. So right here, and then when you are learning database, we say we can declare, like we can use the primary key and all the 2 of them together. Let's say right here, order ID and product ID. Okay, so they were working together as we're in color. Okay, so they can be a primary key, but it's just like combined together, right? In database, like compare with in practical, but in actual, like how we work, actually we always try to create a new ID. Maybe we call it transaction ID like this, and then as a primary key and do it indexing. Okay, even though we need to create a new column, a new attribute. Well, like why are we doing this way? But we need to like create one more column, like one more new attribute. That means we need to have a new ID and then save more data. Then why are we doing this way? In the image right now, we are doing the same. Instead of using like 2 primary key, like as a foreign key. So right now, the foreign key, and then to form a primary key in the new table, I will, instead of like doing in this way, I prefer to create a new column called the transaction ID, and then mark it as a primary key. But why I'm doing this way? Because if I'm doing this, I'm wasting, like one of the ideas, I want to save my storage space, right? But why I'm doing this way? Mhm. Yes, yeah. So it's that mainly some reason. So in practical, that's why when we doing system design, we sometimes we are not really directly apply the um like just like copy from what textbook saying and then put it in practical. And of course, we need to sacrifice the storage size, but at least we are not sacrifice that much of storage space, but we can improve the input efficiency and then reduce the passing parameter. So here's the purpose, okay? And easy to retrieve the record. So when you designing or like if for your assignment exercise or final, sometimes I say give the attribute. So like okay, at least provide 3 attributes. You don't have to think about that. First one always the ID. Okay, even create a new one, give an ID. Okay, and then you can give other extra attributes for your design. And in practical too, if you are working, if you're being a database administrator, database developer, then or like for other project, you can do it like create the ID in this way. Okay, so we are going the first normal form, and most of people we are confused is about the second normal form. Okay, so we have some like functional dependency. So it was saying the relation between the attributes such that the value in the first attribute or set always determines the value in the second attribute. So what they're doing. So we always have a function dependency, have a and have an arrow b. Okay, so it's determined. So what does it mean? Or anybody can explain or actually this one is doing for second normal form. So anybody still remember what's second normal form? Idea, no idea. Or like if I say the functional dependency, so what's the meaning of functional dependency? More.
It's passed by reference instead of passed by value.
For data.
Not really passing. Because that one is sorry to stop. For passing by value passed by in more like programming, the value itself. But this one functional is like actually showing the relationship of those. Or I make it slightly simple. Yeah, you can say.
It's when, specifically in database, and I could be 100% wrong, but isn't it when a foreign key, it happens to be the primary key of another table? So like say, if you say you have like, say, a order,
Mhm.
you would have the order ID, which is independent on itself, but then if you say go to do the product order or transaction, you need the order and the products that they're in to the order and the user.
Actually, it's not really related to the primary key and the foreign key. Yeah, okay, yeah. So all the error and dependence. How about others? Yes.
From what I gathered, the columns in the table are all based on the primary key. So I have a product ID and have a product name, which is based on the product ID, the price, which is based on the product ID.
Okay.
So
Okay. Okay. So just like everything related to this table. Okay. Sometimes we will say, okay, if I have a called the order, okay, I have this product called order. So I have an order ID, and then what are the possible attributes in this order table? Would you put all the maybe order I need to have product information, right? Some like product name, product ID? or like the production day, expiry day, or quantity, price, total, subtotal. Okay, maybe like who purchased the one, or like who make this order, right? So maybe I need to put the user ID. Maybe then do I need to put the username, user birthday, user password? No, okay, not. So here's the idea. So we say the functional dependency is like all those when we join the arrow. So when I have this arrow is like, does the supplier have a really direct relationship with the property? No, we do not need to put it, or like we can using joining table to put into together, because we do have relationship between different tables, right? So at least we need to put the primary key from my table as my foreign key, okay? So it's the minimum, but for other not really directly related to this table, then you need to take it out. Okay. So if let's say I have an order, and then I will have a maybe the date, and then maybe the price, maybe I will have the product ID. Okay, so what may be enough. If you try to put the like product name and then manufacturer information, so they're not really directly is not a functional dependency. Okay, so they are functional dependency to the product table, but not to the order table. They need to like break down to two separate table. Okay, so here's the called the second normal form. So it's a, and then just to make sure the second normal form. So after I finish the first normal form, then we will like move on to the second normal form. So each non-key attribute is only functionally dependent on the entire primary key. Okay. So when you go through this one, let's say the promotion ID, product items, and then they are directly. This one combined two IDs to be primary key. So they maybe have a promo price, but for the product ID, do we need to put a regular price right here for the promo order? No, because we the product items right here, maybe we are able to get it from another table, so we don't have to. So it violates the second normal form, so we need to remove this attribute. Okay, so just thinking for the first normal form, work on the row. Okay, second normal form, work on the column. Okay, that means the attributes. And then later, the third normal forms. If we look at this, can you guess what it's talking about? Like shipping plus tax, item total equals total amount. So here's the idea. So in a solution, either moving the vendor attribute to a new table. Then what's the third normal form? If you look at the example right here, what's the third normal form is doing?
Like, you're including the vendor data because one of the columns is based on the requirements that aren't necessarily the vendor.
They're not necessarily, or like we can actually, we can calculate, like some of them is like I am based on two others, cable or others, then you are not required to, maybe here's a question, if you have a user account profile, so would you save the age of the user? If I have a user and then let's say, okay, maybe user maybe have a name, their name, their DOB, and then I will put the age like this. No. Okay, or if I have to really choose, will you try to save the DOB or age? Okay, but if I want to know the age.
The date of birth is constantly changing based on what time of day or where it's age, and would you have to manually go in and change it every time?
So it's a pretty it's a good example, like I was saying. For the age that you have changing, maybe every time you have to check, and then maybe every day you have to like go through your all the rows in your database one more time, update the age, right? So you are not, actually you do not need to do that. If you want to show the age, what do you need to do? Get the DOB and then get the current time. Current time minus the DOB will be the age, okay? So all those we can calculate and get it derivative. So we will remove those attributes. So that one will be the third normal form, okay? After we finish first normal form, second normal form, and third normal form, then suppose it should be looks like very nice structured database. And then we talk about data types. So will be the storage format, and then we have primitive data type. So they will support by the DBMS, or sometimes we have the complex data type. So they're combined or composition of a primitive data type. So we need to define your own. More common, we have the datetime, or even for time we have some called a date or called a timestamp. Okay, and sometimes we have the integer. Also for the string, you can define even for string format. We can have for text or varchar by the characters. Okay, so all this. And then we have the distributed data based architecture. Or if you still remember, we talked about in the case study, we talked about Uber, maybe Spotify. If we have multiple location, then how can we save those data in different server, data server? So we are decentralized database, so in many locations, but they are not really going to interconnected or synchronization. Homogeneous distributed database. There's multiple location. Then using the same DBMS, so they are coordinates of a global schema. So and then the gross distributed database, they will store at the multiple location and then with different DBMS, and that may have their own their local schema. So that's how it looks like. When we try to access the DBMS itself, it has a schema globally, and then for their own, we also have different DBM system in a different location. Maybe for some of the user or some system, they will access to certain or just one database. You're not requested from the global and then assign them to which one, then you can do it in this way. And then for the implementation approach, we have data replication. So each location has its own copy, and then we'll do synchronization. So we need to think of the backup. Just recall in memory, if you remember, how can we use the sometimes we will add the caching layer, and then for the database, how can we make sure if one of the server, one of the databases database is corrupt, then how can we make sure our server is still online? Okay, so maybe we need to have a copying or make the change. Are we going to update every time, or can we just do it maybe it depends on your system's features. If you are doing online store, okay, maybe you always every second you do have a transaction and saving the record. Maybe you need to back up when you every time read when you write into your database. Okay, but if you are something just maybe for internal use, then you maybe just need to back up finish their work, so the system automatically run it in the midnight. So next day they will have a new copy. So also it's okay. So when you look at it, we have different approach to break down the structure. One is called a horizontal partition. So different rows are stored at different location. Okay, so you need to know sometimes this one also they will ask when you talk about the system design. How will you design the database? If you need to do the partitioning, horizontal partition will be break down the row right here. So maybe we have the US account and then Hong Kong account will be right here. So we put in different location instead of putting in the same. And then when we try to implement the approach vertical, so are we going to put the columns at different location? Then if for this example, why we doing that? If account is horizontal, but here will be vertical. Or can you think about what's the possible situation? Like in the past, for this one, the past number description, maybe here will be like US, and then for the manufacturer will be like in the Japanese partition. Okay. Then how can we decide, is it this table or the records are doing like horizontal partition or vertical partition? How will you do? Like what are the difference between these two type of what's the features? Make sure I think okay, this type of tables I can do horizontal partition. That means like okay, I have two different database, and then I will break down this two row belongs like I will put it in this location, and then the bottom part will be put in another country. But for the vertical partition right here, I'll do it is putting them in vertically.
I think I would do a horizontal.
But why if like, but here's the example, I'll do it in vertical. Then why is not doing horizontal? Or like why you say, okay, then I can do horizontal.
I think, honestly, I think horizontal because it makes more sense to me logically to horizontal because you can basically store each data object like one partition, like when vertically you organize it more differently by data type instead.
Practically it works, but there's some reason why. Actually, I do it vertically is correct, but yeah, why?
Maybe shop only needs to know how many, if I'm let's say I'm a distributor and not
Mhm.
the factory, I don't need to know the schematic number
Mhm.
of the product I'm shipping. I just need to know that the guy that I'm shipping to is out.
Mhm,
So
mhm.
I know he needs more.
Mhm, mhm.
So I only need certain types of information in vertical partitioning,
Okay.
whereas
Mhm.
in horizontal partitioning, we do that because certain accounts may be over here, certain accounts may be over there.
Yeah, true. Okay. Really look at it because right here is about the like bank account information. So really depends on locations. Like if I'm the residents like of the state and I mainly access to the data, like maybe I'm the bank located in US. Actually, I don't have to search those like account in Hong Kong, right? I don't have to do that. Okay, of course, maybe you have the right, maybe it takes longer time, but I have a higher priority to looking for like, maybe if I need to more details for the state, okay. If I put all the records or the rows like all the Americans accounts, bank account, but if this time for your own state, like Texas, okay. So if I divide by the row, then I will move out. But you cannot, but you can't like say, okay, I do the vertical partition. I will take up my user account, last name, and SSN, put it in Texas, and then I put the first name, balance, and date last activity in other location. That is not, it doesn't make sense, right? Okay. But for this one, maybe I only care like, okay, so as what you say, maybe in this location, I only care about maybe part number or description number, then that's what I need. I don't care about the actual like who is the manufacturer. I don't have to access it that often. Of course, you should able to access it, okay? But you don't have to save it like increase the efficiency, or I'm okay with certain latency. It's okay. Okay. Here's the reason. So you need to think about how can we do the vertical, horizontal? If we do some assumption. Later we discuss like if let's say we're taking Ubers, then you need to think say user account, then it should be, if for Uber user account, are we doing vertical or horizontal partitioning?
I think it would be more, they would use horizontal because due to it being more of a customer service style, service, it would be better to have the all the customer's information whenever you search up the name instead of, oh, search up customer, he's in this location.
Mhm.
But like, whereas it required, whereas more manufacturing stuff, cares only about certain certain types of data, whereas horizontal,
Keep going.
where the customers are, where Uber would prefer more, you have all the customers' information active right there at your fingertips.
Mhm.
Whenever you like get a customer put into you accept the customer.
Okay, so it based on, okay, yeah, actually for user account, it's the same concept because for user account, I really like depends on location. But for Uber, how can you imagine what kind of things, like what kind of information you can do vertical partition?
Name, you can do vertical as you first gotta have their primary key, then you need their name.
But I'm saying like some tables, yeah. What kind of like information like you can, if we have a table, I can use it for.
You would need at least their name and then their star rating, as a passenger. Is the main two you really need. If after that, I think everything else is turned. Here's what, and location that they're at current time.
Maybe location, some driver information, or like if I'm this location, I only select what kind of information I just need for this location, or like what kind of.
Well, I would say you need their exact location,
Mhm.
you would need their name, and then, something good to keep for any Uber driver or any passenger is the rating of which the driver or user is. And I'm assuming they start from, I'm pretty sure they're Uber side. Never run them, so.
Now, of course, because we are not really working, we don't know like exactly, but like in our case study, we just like guessing what do they have in their database. So just need to think, and then next we need to have a protecting the database. So we need to have a like, transaction logging. So it's a technique. So we can use it to log record all the unit like change date, time, who did the change, like modify the content. So it just like have to prevent a file, and then we recovery mechanism. Okay. We do something called a rollback. If like we're taking certain like update, insert, and then if we do figure out some fault, and then we can roll back to the previous version. But you have to set it. And then concurrency and then update control for the transaction. And then a piece of like of several steps that either must be compared or none must be accepted. And then also we have the database log. So to apply exclusive control to a portion of the database to one user at a time, and then I will like share or read log. So it can like setting multiple transactions, like they can read the data, but only one user can read it. Okay. Pretty similar to OS to share. And then exclusive or like write log. So maybe there's like one user like to access it, so we log it, let them finish the writing, and we can read it or pass it to another user to write it. And here's the overall the ideas of the database design. And because you do learn RDMS, but I add something extra for the MySQL. Okay, because nowadays you should have some idea if you want to include NoSQL to your system design. Then how can we do it? So you need to know or some of them didn't taking. So for the database, we just try to collect. So for relational, we have MySQL as an example. No, non-relational would be the NoSQL. So for the Uber architecture, as a in reality, but it's really doing is a hybrid. So we are combining relational and non-relational database together. So it's more like complex to like manage the ride request, also like driver assignment or payment processing or something like this. Okay. But we do have the like the rider, the app or driver. So you know we have two different apps. And then we have the like display system, payment system, or scalability. We need to like provide really high user traffic, real-time data processing. Especially maybe we need to like sending the data current location of the driver or sending the current location of your like the rider, the customer to the driver. So we need to keep updating. As in our like all those previous PowerPoint, we did showing like if traditional way using MySQL. So we have the use case, like maybe some transaction management, drivers profile, payment record. So for those, like we can ensure the reliable transaction. Okay, we're looking. So all those data, they are structured. And then for user account, right, detail. So all of them, they can be like centralized in the MySQL database to manage all those way. And for the MySQL right here, maybe you can create a table, maybe user ID, primary key, name, and then you can declare the size. So you need to determine like how large or the length of the data. So the metadata, and then font size. Maybe in different country, we have different lengths, right? And they have different zip code. So we can change based on it. And then maybe for the right, then we have the other like user ID, driver ID, and then like where the start location, end location, and then what's the status right now. Okay, and then the timestamp is one of the data type. So it will save the date and the time. Okay, but for calculation. So date time, the timestamp is number, but from the number you can get it from change it like get the year, month, date, yeah, or actual time. And then we will connect with the foreign key and then references to which table and which ID. So we can using the queries like to retrieve all those history, and then for the joining tables, maybe the account ID, email, so right here. But for real-time analysis, maybe you're adding the NoSQL for your system, right? So maybe mainly is like if you want to handle something in real-time analysis, like maybe the driver's location data or some ride request. We mainly think about like those information in like high velocity data and then scalability requirements. So we will add some flexible schemas like with different data JSON, and then we can add a file inside or inside the JSON file with any array, yeah. And then in the architecture, so we just like cascade for high availability and low latency. So we can declare the data like in this format. So with the ride ID, driver ID, and location, latitude, longitude. And then with the timestamp, so you can see the timestamp. And more need to do just like using the is the syntax of the NoSQL. So we have a collection and then find it and then start. Okay, so we can just check. Okay, I want to see what which one is the in the active status that I can assign, or if I want to check if the driver they are like online, so or like nearby, so I need to calculate. Right now I can get check my location. Okay, so right here, how can you know just like guessing if based on this information we have the driver and then we have a user, then how can we know, or like what's the mechanism or algorithm would you implement like based on this database to assign the nearby driver to the rider or to the customer? You know, how can we like achieve this goal, or how can we do that? Yep.
Can I ask for a reading question?
Reading the question again. Okay, so we know for the app, like for the driver, they cannot really pick like who, but they will have some suggestion, they pick up, assign your ride request, right, to the driver, so they can pick up your order. Okay, so what's the algorithm or the mechanism, how the Uber, like the system, how does it work to assign those
when you
requests to
decide
you,
based
the
on-
driver?
When it's decided based on proximity from the location of the person
Mhm.
compared to the location of the final destination, or well, the pickup location.
Okay, so, but we say, so right now, if you look at the
compare
no,
both
so, okay,
longitude-
so right here is the location, right? So we have the longitude and latitude.
It would compare both, it would use both, because you may be far further and actually. It would first have to take their position, and then it would have to compare routes. It would have to see which route is shorter, and then it would decide based on the route, which route is shorter, but also it could be choose based on which location is closest to the which longitude and latitude is closest to the current, to the destinational longitude and latitude.
When you say we are using the route or,
If
Or
you're,
simple?
if you're looking
How?
for if you're looking for optimal,
Mhm.
optimal would be comparing route data, seeing which one has shorter route data. But if you're just doing base route, if you're just doing a base decision, longitude and latitude will get you down.
but maybe if you don't know that, like on the driver app, so it pops out, so we have so many driver nearby, we will receive a notification or have a pop-up, dialogue. So,
Also,
okay, the requirement, so then how this system works, like if you only have the information like this, we have only, how can we use the minimal data to give the recommendation or push the notification to driver, nearby driver? Okay, we'll check the active, okay, and then for the location, because it's checking the best route, so are we really need to check the route, or how can we use the location data? Latitude and longitude. Mhm.
Does the driver's side have a preference on how far they drive?
As far as I know, they don't have really preference, but for Uber itself, the system, they will set the radius, like based on the customer, the rider's location, they will set the radius like nearby. Yeah, so maybe like 50 miles or like 20 miles nearby. If they couldn't find it, maybe they would make it like extend further away, the radius. Okay, so if I talk about radius, that means you need to know what's the circle, right? Circle radius, we have the longitude, latitude. So based on the center of the location, then it's everything about the map. Because if you know the map location, so let's say I'm right here, so I have the parameter. So if I make draw the circle, I have the radius. And then all the driver nearby, I also have the driver have the longitude and latitude. And then from these 2 points, then we can calculate that radius. It's a map. So that's why it's enough. And also for real time, why we are using the NoSQL? Because we need to do it like in real time. So if I using the like relational database, I've drawn the table doing like for like using SQL, it's too slow. We want to do it really quick. But like within 1 second, we have to update the location. Or like how can you know when you're passing the longitude latitude, maybe they are importing using the API, maybe from other service provider, let's say Google Map. Okay, so actually they don't have to implement their own like map location routing algorithm. They can using the API. Once I pass my destination, so you can think if you need to implement a system, you don't have to do it. Maybe using Google Map API, import, maybe just asking you, okay, please pass a location. First is the longitude, latitude and longitude of your destination, and also pass your current longitude and latitude. So they will calculate the best path for you. Okay, they will return it. Okay, so that means like I just need this information, location information, and it pops up, and then I will check in like filtering. Okay, so what are the active, and then what the nearby radius. Maybe this one depends on the Uber's setting. First, maybe I will try to filter less than 15 miles radius. Okay, minus like less than 15. Okay, so if I couldn't get any active status, then I will add it. So that's may it will take a longer time. I change 15 to 25. Okay, can I find any driver? No. Explain it one more time. Okay, or keep repeating. So also you need to for your system you need to know. So would you try it again? Would you wait or keep expanding? There are no definite answer. Maybe Uber, yes, I will try to like from maybe from 15 to 30. 30 next time will be 100. Okay. If I couldn't get any from 100, then what are you going to do? Have you ever like couldn't find any Uber driver? Never. Or the farthest away? I'm not sure. Have you ever like call Uber from here to or somewhere else? Well, here's I know because in commerce, Texas A&M commerce, can't really know where to like. They don't have so many Ubers driver over there. Maybe nearby like Greenville or something like we call that Rockwall, like really city. So it's around like 40 minutes or 1 hour away. Yeah, so at least like 80 miles away, 50 to 80 miles away. They do try to search, or sometimes they didn't pop up any nearby. So for Uber, they will try to maybe keep expanding. Like first, maybe they will try 3 times, just guessing. Okay, well for this one, I didn't really work in Uber, so I just guessing. Maybe first I would try within 15 miles, so really nearby, and also they have higher priority. So if those driver like within 15 miles, they have a priority 1. So once they try to get this order, I will assign to them, or I will try to make a queue, and then that assign to them, and then I will have couldn't find any driver. Then I have expand to like 30 miles, and if I couldn't, and then I will expand to 100 miles. If I couldn't find any, so I say okay, we doesn't have match driver, so you need to wait, or like you need to search again. Okay. So here's one of the mechanisms. So you can keep like putting in waiting list and then keep looking, searching for driver. It's still possible. And because like we try to find that this one matching, so it's way faster than like higher velocity than using the relational database. But when we design MySQL, we need to think about like schema design indexing. It's really important for indexing. Maybe in the school, like for your exercise, assignment, project, you only have 10 records, 20 records for simulating. But in reality, we generate so many data. So it's important to have an indexing, because indexing, we change the background notation, O equals to 1. Okay. And then scaling, how can we like vertical scaling? So we only looking for certain columns. So it will be faster. Okay. To handle the increased load. And then for the NoSQL, what we need to use like for the data models, like for example, schema to vary like data driver's data consistent model to eventually consistent to allow for faster write and read or sharing. So like to distribute the data like across the multiple nodes, like to enhance the performance. So there's a continue. So here's the structure. So it's compatible for relational and then flexible schema. And then we have strong exit report and eventually consistent use case, maybe account payment. We can use a relational. Then for real time, right checking, keep updating the latitude, longitude. Let me see. And then for MySQL, we always need to think for system design. After you implement, we need to think how can we optimize for the complex. Maybe you would join multiple tables together, sometimes 3 tables, 4 tables. Then how can we increase the speed? Sometimes we need to create the views or like create some like tables. Yeah. If you learn database, I think database they do mention something like this, right? Okay. Okay. Okay, good. And I don't have to explain more detail. And then optimize like for high speed. If we need to like high speed read and write, then we're using like NoSQL. So here's the things, just like extra information about NoSQL, because I don't think you're really learning this. So you can consider like for the project design, or especially nowadays, most of the company, we use the hybrid when like we combine relational and non-relational together, working together. Yeah, based on it. Or most of the mobile apps, they're only using NoSQL. They're no longer using MySQL or relational database anymore. Okay. So you can design.
I have a question.
Yep.
Since you mentioned the project and the project design, if we already know who we want in our groups,
Mhm.
and we have the groups open, can we just pick a spot and have us all just do that? Just
Yes.
already open. So,
You can just pick any spot or any good number, so you can join it. So if you want to do it, like you can take time right now and do it, and just you can just like have any representative. Just want to send me the topic, like I'll open it. Yeah, okay. If this library, I know some students joining online, so you can do it. Okay. Yeah. Just avoid the conflict.
What were you supposed to do? Or I didn't.
For the actual project.
Yeah.
Okay, so have similar for the actual project, you need to pick I will give you the more detailed guide, but right now just letting you know. Okay, so you can choose some existing some company or service they're doing right now. Okay, except Uber and Spotify, because I use this a lot. So start with the beginning. For the system design, what's the first step? Do you remember? Yes, requirement, but say we cannot do the questionnaire or like doing the like asking, right? So as a student, so I just like let you have some assumption, okay? Just like give some assumption. Existing.
Okay, clearly they wanted
This, yes, correct. So that's why I say looking for some existing company or service like app they're doing. So you're easy to get those requirements based on what they have. Because we make the step in reverse, but it's easier like as a student like getting. So you look at those functions and say, okay, that's what their requirement. So this is the first step. And then what's the second step?
Define use cases.
Okay, so all those like use case, all those diagrams, that's what you need to draw. Okay. Maybe I will try to like break all this into different process. So you have stage. So let's just submit so it won't like fall behind. And then after you draw all those use case, what do you need to do? Yeah, diagram or diagram. But for this one, actually as a compete, as well I know, because for the system design, you don't have to really like implement the your like all the source code, but at least you should able like give all the use diagrams, ER diagram, and also maybe your database design, and also those like flow, those chart, like telling me okay how we're going to design. So far will be enough in this stage, but of course, if you can tell more like actual structure, let me see. I didn't post it, but I think I do have something of a picture. If I have something. No.
How large of groups are you wanting?
Because we're 20 something, so we don't have enough. Maybe around 4 to 5. Okay, so I say around 4 to 5 because we only have like 29 students. If you're 4 to 5, we only have around 4 good 5 or 6. Okay, so around this range, so it's okay. And let me see if any of you already registered. So okay, I'll get the first group, so which is fine. So others you can like take group 2, group 3, and then which is it. And just like choose the just need to give me the topic. So you have sometimes
What is the sort of project? What is it? Like, what topics are we able to show?
I say I would recommend that exists like company or the all those apps you're able to see. But when I choose Spotify and Uber, so don't take the one I use for the like case study for a class. Not only app, but anything like other service, yeah. Okay, so the reason why I letting you picking existing, you don't have to like guess or I think because I think other group they ask what's the first step? We try to get the requirements, right? User requirement will do the questionnaire and then they some interviews. Of course, we are not really able, you are not able to doing like questionnaire or you're not maybe the actually stakeholder user. So based on those exist company, then you're able to get or like guess what are the actual requirements for the user. So it will be easier. So you can look at their maybe they only have website or they only have some certain service. Then you look at okay, what kind of possible requirement they need to have. So you go through all the details. Let's say I'm using Uber again. So what are the requirements for the Uber? And it's like for the user, I need to order the like when I input my location, that I should able to get the drivers, yeah, as I order, and then I should able to check my user information, and then maybe I can change my record history. Maybe I want to check the users background, maybe some information. So there are all the requirements. Because if you never really working for a certain company, you maybe have no idea. But when you look at those actual exist website, mobile app, they'll know, okay, so you can, based on what they have, you'll know what are the requirements you need. So based on those requirements, and you should able to, what's the next step? Like we talk about Star, right? They use diagram database. So how do so you need to think about also the whole structure. If you are like being able to doing more, showing the whole complete structure of the Uber, like when we from the user, from the client, how can we send the API? So how will you design API server and then how to design your database system? So we talk about this database system. Also, we in the previous week we talked about the UI. UI design how based on the use case, also the flow. Then how will you design the UI? Okay. More advanced, you can think about the UX, user experience, how can design. So maybe you need to show me that layout. So it's not that simple, only a diagram, but if you need to work like, thinking about the UI, then you need to show me, okay, so if based on this, but I will recommend not only like copy from what they have exactly, but you I will recommend one more thing like later, one more station, add some special feature you think would be useful. Yeah, so instead of just otherwise just like copy what they have and then present to me. But I recommend say, okay, if I need to add one more feature, recommend one more feature. Yeah, I say Uber. Last time we talked about or like Spotify. I want to share my what's the last time we talked about? Do you remember? Yeah, we use Spotify, but I think I'm saying something to add some special feature, but I forgot. Share the playlist or not share playlist. Okay, I forgot. So let's say that one it doesn't really exist, like or like Spotify doesn't doing this. But if I want to add this special feature, then how are you going to modify the data structure? So also the use case. So it's like testing how much knowledge like you knowing for the system design and then understanding of the database also. Yeah. So are you choosing the regular like relational database, or for the new features, are you going to use the non-relational database? That's how we decide. So that's how it looks like. So I will try to give you more guideline, but in this stage, try to form a good and give me a topic like choose. Maybe you need to meet with your good mate and then think about which one. Maybe you need to study And then at least topic, and then I'm trying to ask your. I'm not yet posted. But what you need to like topic and then at least give me some like basic background of this the one you choose. Okay, the company or service you want to do. Okay, so here's the first one. And that's it for today's class. If you have more question about the good project, you can ask me. And then if you need to clarify anything, I will let you know.